Hey everyone, so now we're going to be talking about how to solve systems of three equations. Unfortunately, this is a little bit tough and it takes quite a while to kind of figure out, but hopefully I do a good enough job at explaining it so that you guys can do it. You can solve systems of the three equations by either substitution or elimination. It doesn't matter which one, it just kind of depends on what each system looks like. So what we're going to do is start with two examples that we use substitution on, and then we'll do two examples with elimination. So first example is okay. So we've got y equals negative 6, y equals negative 2x plus 5z plus 7, and then z equals negative 4x plus y minus 23. So as you can see, we've got three equations and three variables. And this one is actually makes it a little bit easier because um, we automatically have one of the answers. It already told us that y is equal to negative 6. So I'm going to just kind of box that up because that's one of our answers. For this, um, we're going to have three answers. We're going to have an x equals answer, a y equals answer, and then a z equals answer. So we already have one of those. Um, and when we already have one of them, the first step that we're going to take is to plug that answer into both of the equations. So for y. So I'm going to just rewrite the second equation, but replace the y with negative 6. So it's going to say negative 6 equals negative 2x plus 5z plus 7. And then the third equation will be z is equal to negative 4x plus, but instead of y, we know that y is negative 6 minus 23. All right. So now what we can do, I'm just going to simplify these equations by combining like terms. So that top equation, what I can do is move the negative 6 over to the other side by adding 6, and I end up with 0 equals negative 2x plus 5z, and then plus 13. And for the second equation, I'm just going to combine like terms, the negative 6 and negative 23, so that I get z is equal to negative 4x minus 29. Okay, so now, once again, we're going to use substitution, just like we substituted the negative 6 in for the y's. We're going to take that second equation that we have now, that z equals negative 4x minus 29, and substitute it in for the z in the top equation. So we're going down to one equation, and it's that top equation, 0 equals negative 2x plus 5, but instead of saying z, I'm going to replace that z with what I know that z is equal to, which is that negative 4x minus 29. And then we've got that plus 13 at the end. So now we only have one equation and one variable, so we can actually take this and solve it for x. To solve it for x, we're going to start by distributing the 5 inside of this set of parentheses. Get 0 equals negative 2x minus 20x minus 145, and then plus 13. And now I'm going to combine like terms, which are my x's and then my things without the x's. So I get 0 equals negative 22x minus 132. All right, now I want to solve this for x. So the way that I'm going to solve it for x is by adding 132 on both sides. I get 132 is equal to negative 22x. Then we're going to divide both sides by negative 22. And we end up with negative 6. So I get negative 6 is equal to x. All right, so there's a second answer. So now I have x equals negative 6, and from the top I also have y equals negative 6. So once I have two of these answers, what I'm going to do is take, I can take one of the equations, and it doesn't matter. I could go back to one of the original equations, or I can use one of these simpler equations. And I'm actually going to use this equation right here, and plug my answers back in to find that z that I'm looking for. So I know from this little starred equation that z is equal to negative 4x minus 29. But I also know that x is equal to negative 6, so I'm going to replace the x with negative 6. So I get z is equal to negative 4, but instead of the x, I put negative 6 minus 29. Okay, now I get z is equal to negative 4 times negative 6 is 24 minus 29, which gives me z is equal to negative 5. And there's my third answer. So all in all, my answers are x equals negative 6, y equals negative 6, and z equals negative 5. So that wasn't so bad. All right, but let's look at the next example. For our next example, we have 5x plus y equals negative 19, negative x minus y plus 5z is equal to negative 6, and then x is equal to negative 3y plus 13. So what we're going to do, we still want to use substitution on this. And one thing that clues me into the fact that we want to use substitution is because one of the equations is already set equal to a variable. So that bottom equation is already set equal to x. So substitution might be easiest. What I'm going to do is take the top equation and the bottom equation and replace the x in the top equation with what I know x equals, which is that negative 3y plus 13. So I'm going to do that down below. So I'm going to just rewrite 5, but instead of x, I'm going to say negative 3y plus 13 and plus y equals negative 19. Now, if you look really close, we only have one variable in this equation. So instead of starting to plug stuff into that second equation right off the bat, what I'm going to do is actually solve for y. So I'm going to distribute the 5 inside of these parentheses. I get negative 15y plus 65 plus y equals negative 19. All right, now we're going to combine like terms, the y's, and we get negative 14y plus 65 equals negative 19. Now we can solve this for y by subtracting 65 from each side. We get negative 14y equals negative 84. Then I want to divide both sides by negative 14. And I get y is equal to 6. All right, so that is one of my answers. And we can actually now go back to the third equation, the third original equation, which is right there, and plug that 6 in for y to solve for x. So I'm going to say x is equal to negative 3y plus 13, but I know that y is 6, so I'm going to say x is equal to negative 3 times 6 plus 13, which would give me x is equal to negative 18 plus 13, and negative 18 plus 13 is a negative 5, so now I know x is equal to negative 5. All right, cool. So now we have two answers, an x equals answer and a y equals answer. So now we just need the z equals answer. If you go back to the original equations, which are right here, there's only one equation with a z in it. So we're going to use that middle equation because it's the only one with a z in it. I'm going to just write it down here. Negative x minus y plus 5z is equal to negative 6. And I'm going to replace the x and the y with what I know they are. So I'm going to have negative 5 minus 6 plus 5z equals negative 6. All right, now let's just simplify and combine like terms. So two negatives together make a positive. I get 5 minus 6 plus 5z equals negative 6. 5 minus 6 is negative 1 plus 5z equals negative 6. Now I'm going to add 1 to both sides. To get the z by itself, I get 5z. So I'm going to scroll this up. Equals negative 5. And then divide each side by 5 to get the z by itself. and I end up with z is equal to -1. There's my third answer. So all in all, we have x equals -5, y equals 6, and z equals -1. There we have it. So those two examples went over how to solve by substitution. Now we're going to look at some examples that talk about how to solve by elimination. So the third example is -4x plus 2y minus 4z equals 20. -4x plus y plus 3z equals -6, and 4x minus 2y minus 3z equals 8. So the first thing I want you to notice here is that all of the x's and y's and z's are lined up, and we don't have one equation that's solved for a variable. So that's a really good clue to know that it's easier to solve by elimination. So when we solve by elimination, what we're going to do is actually kind of combine two equations at a time to get two new equations and then solve from there. What I want to do is combine the second and the third equation first. When I say combine, I really mean add the second and the third equation together first. The reason why I'm choosing the second and third equation is because if you look at the x's, we have a +4 and a -4 on the second and third equations, or I'm sorry, a +4x and a -4x. And so those things should cancel out. And that's a really good thing. We're trying to eliminate something, and so we want to eliminate the x's. When I combine those two, I end up with the 4's cancel out. Then we have y plus a -2y gives me a -y, and a 3z minus the 3z, actually, they cancel out as well. So I can just put an equal sign, and then we have a -6 and 8, which gives me 2. So now I have -y equals 2. That's a really easy thing for me to solve, so I'm going to just divide each side by -1. And I end up with y is equal to -2. And sweet, there's one of my answers already. Now, what I can do is what the next step I want to take is to combine the first and the last equation. And the reason why I'm choosing the first and last equation is, once again, because I've got a -4x and a +4x, and so those should cancel each other out. So I'm just going to rewrite those two together so we can see them a little bit better. All right, so now we can add them together. We got a -4x and a +4x, so those cancel out. And then we have a +2y and a -2y, so those cancel out as well, which makes it a little bit easier. And then we have a -4z and a -3z, which gives me a -7z. And then 2 and 8. Oh, I'm sorry, this was a 20. There we go, that makes more sense. 20 and 8 gives me a 28. All right, so now we can solve for z by dividing both sides by -7. And I end up with z is equal to -4. All right, so two answers. We've got a y equals answer and a z equals answer. To find the x equals answer, we're just going to go back to one of the original equations, and I'm just going to take that top equation. Let me rewrite it down here. And we're going to replace the y and the z with what we know that they are. So I'm going to say -4x plus 2, but instead of y, we're going to put a -2 because that's what y is, minus 4 times -4, because that's what z is, equals 20. Now let's simplify this. So we've got -4x minus 4 plus 16 equals 20. Now we can combine those two like terms, which gives me -4x plus 12 equals 20. Now, to get the x by itself, we're going to subtract 12 from each side. We get -4x equals 8, and then divide by -4 on each side. We end up with x is equal to -2. All right, so now we have three answers. Let's just write them all down. We get x equals -2, y equals -2, and z equals -4. Awesome. Okay, let's just go through one more quick example. And this example is negative x plus y minus 5z equals negative 11, negative 5x plus 4y minus 6z equals negative 13, and 3x plus 3y plus 6z equals negative 9. All right, so unlike the last example that we just went over, there's nothing that will just automatically cancel out. It looks like the two bottom z's will cancel out, but then it's going to be kind of hard to get the two top z's to cancel each other out. So what we're going to do is actually we're going to get rid of the y's. The reason why I'm choosing the y's is mostly because we have just a regular y on the top, so I can multiply that by the 4 and the 3 the way that I need to. So what we're going to do is we're going to start with these top two equations. And to get rid of the y, I want to multiply the top equation by negative 4. So when I multiply it by negative 4, I'm just going to rewrite it down here. I would get a positive 4x minus 4y. So remember, sorry, we're multiplying this by negative 4. Plus 20z equals positive 44. All right, now I'm just going to rewrite that second equation, which gives me negative 5x plus 4y minus 6z equals negative 13. And we're going to add those suckers together. You'd get negative x, the y's cancel out like what we want them to do, and then plus 14z equals 31. Okay, now just kind of keep that in your back pocket for a second, because now what we're going to do is I'm going to erase just this negative 4 right here and this. In fact, watch this. We'll do these two are the red equations. Now let's do some blue equations. And the blue equations are going to be the top and the bottom one. And once again, we want to get rid of the y's, because what will happen is if we get rid of the y's again, we'll end up with just an x and a z, and then we can have a separate system of equations with just x's and z's to solve, like with just two equations. So for the blue equations, what we're going to do is multiply the top equation by a negative 3. And the reason why I'm choosing negative 3 is because if I multiply by negative 3, the y's from the top and the bottom should cancel out. So when I multiply that top equation by negative 3, I should get 3x minus 3y plus 15z equals 33. Then I'm just going to rewrite the bottom equation, 3x plus 3y plus 6z equals negative 9. Now we can add them together. This is the blue equations. So when we add them together, we get 6x, the y's cancel out like what we want to, plus 21z equals 24. All right, so now we have, let's make them the green equations. These two equations would just have the x's and the z's. So I'm going to write those two out down here. Sorry. We've got negative x plus 14z equals 31. And then we've got 6x plus 21z equals 24. Okay, so this is like a normal system of equations. We're going to just solve it with elimination because it's already set up that way. So I'm going to multiply this top equation by negative 6 to get rid of the x's. When I multiply it by negative 6, I'm sorry, not negative 6, because we want to multiply it by just 6, because we won't want the negative to stay there. So when I multiply it by 6, I get negative 6x plus 84z equals 186. And then we're going to leave the bottom equation alone, 6x plus 21z equals 24. Now we can add those together, and we've got a negative 6x and a positive 6x, which cancel each other out. And then we've got 84 plus 21, which gives me a 105z. And then 186 plus 24 gives me 210. All right, so now we only have one equation with one variable, which means that we can solve it for z by dividing each side by 105. And we get z is equal to 2. All right, so 1 down, 2 to go. Now that I know that z is equal to 2, what I can do is go back to one of my green equations, which were these two right here, and plug that z in for that 2 in for z to solve for x. So I'm just going to start with that top equation, which is negative x plus 14z equals 31. We're going to plug in 2 for z, so we get negative x plus 14 times 2 equals 31, which gives me negative x plus 28 equals 31. To get the x by itself, I would subtract 28 from each side. We get negative x equals 3. I don't like that it's negative x. I want it to be positive x, so I'm going to divide each side by negative 1. And we end up with x is equal to negative 3. All right, so now we have 2 of our answers. We just need the y. So to get the y, what I'm going to do is go back to one of my original equations up here. And we'll just take that top equation, the negative x plus y minus 5z equals negative 11. And I'm going to replace the x and the z with what I know they are, so the negative 3 and the 2. So I'm going to have negative 3 plus y minus 5, but instead of z, I'm going to put a 2 equals negative 11. And then we have the two negatives cancel each other out to make positive 3 plus y minus 10 equals negative 11. We're going to combine like terms, the 3 and negative 10, so I get negative 7 plus y equals negative 11. To get the y by itself, I would add 7 to both sides, and I end up with y is equal to negative 4. All right, so now we have all of our answers. We have x equals negative 3, y equals negative 4, and z equals 2. And there we have it. So systems of equations with 3 equations is tough because there's a lot going on. Notice how I use like different colors to represent different things on here. That might be a little bit easier for you to help you organize your work. Just make sure that whatever you're doing, that you're trying as hard as you can to keep organized, because it's going to get really messy really fast if not.